Welcome to this comprehensive tutorial on using blockchain for supply chain transparency. In today's fast-paced world, maintaining transparency in supply chains is crucial for building trust and efficiency. In this video, we will explore what blockchain is, why it is important for supply chains, and how to implement a basic blockchain application that can enhance transparency across various steps of the supply chain. Let's start by understanding the fundamental concepts of blockchain technology. Blockchain is a distributed ledger technology that allows multiple parties to save and share information in a secure way. Initially developed as the underlying technology for cryptocurrencies like Bitcoin, blockchain provides a means of ensuring data integrity through cryptographic hashing and consensus mechanisms. Now, let's dive into why this technology is particularly suited for supply chains. Transparency is key in supply chain management. By utilizing blockchain, we can create an immutable record of all transactions, ensuring that each step taken from origin to destination is verifiable. Imagine this scenario. A consumer wants to buy organic tomatoes and only from a specific farm. Blockchain can provide a traceable record of the tomatoes' journey from the farm to the supermarket shelf. Let's see how we can implement a simple blockchain application in Java for tracking products through a supply chain. To begin with, we will set up a basic Java project. You can use Maven for dependency management. Project XMLNS equals http://maven apache.org/pom/4.0.0 XMLNS sci equals http://www.w3.org/2001/XML schema instance. Sci schema location equals http://maven.apache.org/pom/4.0.0 http://maven apache.org/xsd/maven-4.0.0 xsd. Model version 4.0.0 /model version. Group ID com.supplychain/group ID. Artifact ID blockchain supply chain /artifact ID. Version 1.0.0 /version. Properties maven.compiler.source 1.8 /maven compiler.source. maven.compiler.target 1.8 /maven.compiler.target. /properties /project. Once your project is set up, let's create a class named block that will represent each block in the blockchain. Each block will contain data, a hash, a timestamp, and the hash of the previous block. Import java.util date. Import com.google.json. JSON. Import com.google.json.json builder. Public class block. Private string previous hash. Private string hash. Private string data. Private long timestamp. Public block. String data. String previous hash. This.data equals data. This.previous hash equals previous hash. This.timestamp equals new date. Get time. This.hash equals calculate hash. Public string calculate hash. String calculated hash equals string util. Apply SHA-256. Previous hash plus. Long to string, timestamp, plus. Data. Return calculated hash. At override. Public string to string. Return new JSON builder. Set pretty printing. Create. To JSON this. In our block class, we're using SHA-256 for hashing. You will need to implement the string-util class with the SHA-256 function, and using JSON to easily convert our block data into JSON for output. Import java.security.messageDigest. Public class string-util. Public static string apply SHA-256. String input. Try. Message digest equals message digest. Get instance. SHA-256. Byte. Hash equals digest. Input. Get bytes. UTF-8. String builder hex string equals new string builder. 4. Byte B. Hash. String hex equals integer. To hex string 0xFF and B. If hex.length equals 1, hexstring.append 0, hexstring.append hex, return hexstring.toString, catch exception E, throw new runtime exception E. Next, let's implement the blockchain itself. Create a class called blockchain to manage our blocks, add new blocks, and maintain the chain integrity. Import java.util.ArrayList, public class blockchain, private ArrayList block chain, public blockchain, chain equals new ArrayList E, // adding the Genesis block, add block, new block, Genesis block, 0, public void add block, block new block dot previous hash equals this, get latest block dot hash, chain dot add new block, public block get latest block, return chain dot get chain dot size 1, at override, public string to string, return new JSON builder dot set pretty printing dot create dot to JSON chain. In our blockchain class, we initialize the chain with a Genesis block. Whenever we add a new block, we set its previous hash to the hash of the last block, ensuring integrity. Now, let's create a simple demonstration of our blockchain in the main class. We'll create a few blocks representing supply chain events such as produce harvested, packed for shipment, and shipped to distributor. Public class main, public static void main, string, args. Blockchain supply chain equals new blockchain. System.out.println, blockchain created. System.out.println, supply chain. Supply chain.addBlock, new block, tomatoes harvested. Supply chain.getLatestBlock.hash. System.out.println, block 1 added. Supply chain.addBlock, new block, tomatoes packed for shipment. Supply chain.getLatestBlock.hash. System.out.println, block 2 added. Supply chain.addBlock, new block, tomatoes shipped to distributor. Supply chain.getLatestBlock.hash. System.out.println, block 3 added. When you run this code, you can see the progression of the supply chain events added to the blockchain. Each event is linked to the previous one through its hash, ensuring that the entire history is immutable. We can even expand our blockchain model to include more detailed information, such as timestamps, product specifications, or even digital signatures to validate the authenticity of the transactions. Now, let's discuss some potential real-world applications of this technology. For instance, major companies like IBM and Walmart have begun to experiment with blockchain to enhance transparency in their supply chain processes. Walmart has utilized IBM's Food Trust blockchain to trace the origin of food products quickly, enabling them to respond to food safety issues much faster. This is just one example of blockchain's power in real-world applications. In addition to food supply chains, this technology can be applied in various industries including pharmaceuticals, luxury goods, and even logistics, where tracing the authenticity and journey of products is critical. As we conclude this tutorial, let's recap what we learned. We started with the basics of blockchain technology and its significance in creating transparency within supply chains. We implemented a basic blockchain in Java to visualize product tracking from farm to shelf. This model is a foundation for building more complex systems that incorporate additional features like decentralization and real-time monitoring. I encourage you to further explore blockchain technology and think about how it could be implemented within different use cases in supply chains across various industries. If you found this tutorial helpful, please give it a thumbs up and consider subscribing to my channel for more content on Java programming and emerging technologies. Perhaps you are interested in building a decentralized application next? Thank you for watching, and I look forward to seeing you in the next tutorial.